Tune into this week's Xamarin Show where my good friend Alexey is coming on to show us how to bind Swift libraries for iOS. Welcome back, everyone, to the Xamarin Show. I'm your host, James Montemagno, and today, my best friend in the entire world, Alexey, is here to talk to us about bindings.
Oh my God. Hi, guys. Thank you for having me back.
Yeah, so what are we talking about? You said you wanted to come talk about bindings, but maybe first, what are bindings and why do people need them?
So whenever you try to use any native functionality from a third-party developer, and it is a native functionality, you cannot just drop it in your Visual Studio and start to use it. You have to have some kind of wrapper. And this wrapper we call binding. Bindings there are for a long time already, right? Since the very beginning. But there are a few new tools coming from native world, like Swift tool, Swift language, which doesn't work out of the box. And I would like to talk how to do that today.
Cool. So today, Swift bindings, and maybe for people that don't understand, it sounds like you said the binding technology has been there for a while, and a lot of developers are probably used to going to NuGet and saying, oh, I get this cool new C# functionality.
Right.
So this is non-C# native iOS and Android libraries.
That is correct.
Okay.
And those libraries are usually distributed as frameworks and probably different channels, not NuGets. And sometimes developers actually working on these kind of NuGet packages, so let you as a Xamarin developer to use those libraries. Sometimes they don't even know about Xamarin, and that's when we need to work on bindings.
Gotcha. So yes, so to some developers might be used to this using like Android support libraries, or like you said, going onto NuGet and you see, third-party libraries from different companies that have native SDKs. Now they have a Xamarin binding on top of it, and it's sort of how Xamarin works, right? Just for the built-in ones. All right, so let's talk about Swift, because some developers might have been used to just taking an Objective-C archive, binding library, boom. But Swift is different. So what are the approaches to binding a Swift library?
Swift is different, and there are two approaches to bind this kind of third-party libraries. First approach is a usual approach when you go with Objective-C header and kind of pretending to be an Objective-C app, and that's how we do regular bindings for Objective-C code.
Okay, so you have a Swift library, and then you create Objective-C headers. So it's like a glue layer.
Kind of.
And then you would go through the normal stuff.
Consider it to be a proxy or metadata, how to call Swift world through Objective-C.
Got it.
And usually third-party developers pack in these Swift libraries with Objective-C header embedded. But there are cases when they don't, so you have option for that as well.
Oh, okay, gotcha. So a lot of developers may be like, this is a Swift only, you can only call it from Swift.
Right.
Then there's no headers.
Yeah.
But a lot of, especially probably older libraries, have two-way.
By default.
Cool.
And there is also a second approach, which is new approach. I highly encourage you to try it on. It's binding tools, which is a new tool from Microsoft. So Swift tools, binding tools for Swift. And you can use this. It will magically allow you to use a framework, which is Swift framework, and just it will work out of the box.
Okay.
But today I'm going to cover the traditional approach, which is more probably complicated, but will be able to cover more cases. Basically, whenever you hit an issue, you won't be blocked by that. You will still be able to bind any Swift library with that.
Gotcha. So maybe go try the new tool, which we'll put links into the show notes below first.
That's right.
In fact, maybe we'll have you come back on and I'll do a whole new video on that.
Most likely.
But try that out. If it works, great. Awesome. And if it doesn't, tried and true approach, kind of.
Yep.
All right, let's get into it.
Let's talk about that. So I put some information together at a blog post, which will come in soon. It's already available on GitHub, and it is right here. So usual approach, it's agnostic to any platform. It basically contains 4 steps. First of all, you need to have a native library. So native library, which is packaged as a framework or whatever. Then you have to prepare metadata. Metadata will say how to call this native library from the managed world. Third, you need to create a binding, which we already talked about, which is a Visual Studio project. And fourth, you have to create an app, which will use your binding, and it goes one after another.
Yeah, so the last few steps seem very easy, which is take a library and consume it, right?
Last two steps are already just in Visual Studio. You're
Yeah.
pretty familiar with that. You'll just go and create a few projects, drop a few files, and just run the app.
Perfect.
But first two steps probably would be more complicated for you. As a Xamarin developers, you have to know some native tricks. You have to use Xcode tool to build the native framework and work from that.
Gotcha.
So let's talk about first step and the most complicated step. So first step is building native library. I was working with a few customers recently, and one of them was using Giga Swift SDK. So we tried to bind this SDK, which is Swift, basically a native library. If you go here, you will be able to download the package, which knows nothing about
Objective-C or Xamarin or anything, just Swift.
Yeah, that's right. And whenever you download this package, it gives you a plain old framework. So next step, you have to create a framework wrapper. So you would like to access this framework from your code and provide an access to managed world.
Okay.
This proxy is not required. Whenever this package or any third-party package comes with the Objective-C header, you can use it out of the box. So whenever this Objective-C header exposes whatever you need, you will be able to call in from Xamarin.
Gotcha. So this, I want to be, that you have the source code, you just have the framework, right? Or do you have the source code for the project?
It is a framework.
Okay.
It was another complication. The version we were working before didn't have any source code.
Oh, okay.
So you were unable even to modify this header and expose members you need. So
Okay.
if you open this framework, which we downloaded earlier, it has this Swift header, which is an interface to call in. But it actually doesn't have anything about members. You cannot create an instance of the Swift Giga SDK instance. You cannot call into members. So, as instead, now we have to create this proxy.
Gotcha.
And proxy is a simple class. I like this approach because, first of all, it doesn't block you on anything. Whatever is not exposed, you still can call in and expose it. Second thing, you can define your interface as convenient as you need. So you would like to hide some members, go for it. You would like to rename some members, go for it.
Yeah, or maybe you only need 2 members out of 100 of them. You only need to really expose that many, I assume.
That's right, and that's what we expose here.
Oh, cool.
So basically, we would like to initialize the framework and add the login functionality.
Okay.
We also follow a few rules saying like it should be Objective-C member and specify for this project for the header to be generated. Whenever we build this framework, we have this Swift framework proxy file, which actually a package containing another framework and our header. If you open this header, and I have already it opened here in Visual Studio. Oh no, I have it here. So if you open this header here, you will see a few members. And this is an old way. So this is our init for API key, login with provider, and it's an auto-generated header. That's how we can call this library from Xamarin World.
Gotcha. So that sort of, inside of Xcode, you have the header, which then when you generate it, creates that. So this is sort of the contract, then puts that header information into the framework.
That's correct.
So this is sort of like your API, and then it gets kind of bundled into the final framework that you would then create the binding for.
Yes, and that's done automatically by Xcode. You just need to switch on this small little option here in build settings. It is very hard to see from here, but
it's called, let's see, Objective-C.
Yep. So if you look here, you will be able to see this Swift framework proxy -Swift. It has this name by default, but you can rename it. I wouldn't suggest to do that because everybody expecting this name to be here. And you can completely switch it off. And that's what some developers do. They actually switching it off, saying, OK, this is a Swift library, use it from Swift app. We don't care about Objective-C.
Gotcha.
But we, as the Xamarin developers, we still care. And we have a way to still enable it by using a proxy. We created a framework, calling it a proxy, adding a reference to native Giga SDK, and switching off this proxy header.
Gotcha.
So let's say we want to add a new method. We call it Objective-C, and func test James. I like this name.
I like that name too.
And let's build it. Uh-oh, build failed. Why is that? Sorry, let's redo it. Probably we don't need to do this. Probably I changed something there. Oh, can we redo this? My source code was broken before. Let's restart.
Yeah.
Okay.
So let me open this. I want to start from the adding new member
Okay.
here, showing that it will populate the SDK.
Yeah. So yeah, go from there and then say, so these are the two that I have. Let's add another test method. Yeah.
Okay, though these two that I have, and let's add just a new member here. Let's call it Objective-C and call it func test James.
It's a good method. I like it.
Love this name. Let's build it. And if you go here, you won't be able to see this method because it wasn't following all the rules which we need to apply to expose this member. Again, this is auto-generated, so we have to follow some rules. So one of the rules is to make it public. Also another rule to have it Objective-C marked. And if you build it now, we will be able to see this method right here. I won't be reopening this file, but basically that will appear right here. That's all you need to do. I've described all the rules right here when you build in this framework proxy. And if you follow all these rules, switching all the options, including Objective-C generated header, you will be able to get this contract.
Gotcha.
Some important steps are also more specified here. You will be able to use those. Also stay alert on the naming because name will be auto-generated as well if you won't define it. And you won't like these names with these lots of symbols and underscores. So this is the first step and very essential. The complicated doesn't use any Xamarin tooling at all for now. We just use an Xcode, native library, created a proxy. Our proxy is a framework. So now we go and create a metadata for this framework, which is probably already familiar with this. You're creating a regular Xamarin binding, Xamarin iOS binding, and need to define these API definitions, structs, and enums. For now, as long as we're exposing just two methods, we're saying that it should be two methods init for API key login with provider, and also we specify how to call this method. And that's the Objective-C definition, how we call in, how we send in these messages to Objective-C world.
Got it.
Without that header, we won't be able to call in, and nothing would work.
Are there tools to auto-generate this somehow, or did you have to generate this yourself?
That's a good question. There is a tool, and it works the same way as for Objective-C, because it's Objective-C header called Sharpie. You can download it. It's publicly available. And usage is just simple. You call this Sharpie tool saying, here's your header, here's your namespace, and boom, it generates this interface, which is called interface, but it actually will be generating C# classes, which you're going to use.
That's beautiful. That's nice because then if you're defining it, you follow the rules, the tool will easily be able to generate it because everybody's happy.
That's right. And that's another advantage of using your own framework. You control the flow on your own.
Nice.
Important part, don't confuse it with interface, because in your code, in your app code, Swift framework proxy will be a class. So you're going to create a Swift framework proxy class instance and call it from the native forward.
Got it.
So second step was to create this protocol or auto-generate. And again, I also put some information about this in the blog post. So this is tool Objective-C Sharpie. And also, you will be able to use this helper script, which I created, to generate this metadata.
Very cool.
What it does, it just generates the two files which you have to use later. You basically have to copy them here.
Beautiful.
Third step is to create this binding properly. So you have to add all the native references. You have two now. You have GigF framework, which is first one.
And then yours.
And
so
your-
you have two of them, yeah.
Yeah, you have to pull both of them. And sometimes there is not obvious, and your app will instantly crash without any information to you, because it's hard. It will be hard to find. But you actually have to add this native library as well here.
Makes sense.
And
it's sort of like when you have a plugin or something cross-platform. If you only have the .NET Standard, you don't have the native implementation. So this is sort of the interface, but not the implementation for the platform. That's clever. I like it.
That's correct. And also, this Swift framework proxy is a very small framework. It's lightweight, so don't be worried about that. Also, you have to set a few important properties right here. Like frameworks, it depends on. Like if it's a C++, if it's a framework. You also would like to not to force loading, because this is important for Swift libraries when you're doing it through this approach. For some Objective-C libraries, you need to switch it on, so this is uncommon. And again, it's all outlined in the step-by-step guide.
Perfect.
Once you have it, you will be able to build this project and use it in your app. So the final step is to create your app, and you're probably already familiar how to do that.
Yes.
So how to do that?
File new app.
That's right.
And then add a reference.
Yes, that's as easy as it. File new app,
Done.
add a reference, no other options needed, just add it, and that is it. The app will just run. No need to add any dependencies, no need to configure any linker flags, because you already configured it in your binding.
Oh, nice.
And it will work just out of the box. Let's run this app. Let's also see what we do inside. So this is our interface. Remember, I was telling that we defined an interface. It's basically a class. So Swift Framework Proxy is a class which you can create and call the method here. Whenever we get in the results, we just print in output and submitting it to label.
Cool.
Let's
Easy
start.
peasy.
Let's start it, and it should work out of the box.
So what we're seeing here is this proxy layer. So instead of calling the Giga SDK directly, you're creating your object, calling the APIs, which sort of passes through and down through that interface that you created.
That's right.
That makes sense.
Objective-C is a key here, Objective-C header, and you totally control it, completely defining your interface as you want it.
Gotcha.
So you see this is Giga initialized with domain, this value coming already from a Swift library. It's not even coming from the proxy library, it's coming from the embedded library inside
Gotcha.
of it.
Yeah.
And it works out of the box. I don't have an API key, but this login button will initialize the login provider, which actually already part of SDK. This window I didn't create it manually. It was created by SDK internally, and I don't have any control. SDK provides me a callback option, so I pass in my callback. Whenever I close in, I'm getting this callback here.
Nice.
And that is it.
That's it.
Yeah.
Easy peasy. And then you can, I assume at that point, if there's callbacks, you could spice it up with asynchronous stuff and kind of make that your own too, to add more C-sharpy things onto it.
And that's another beauty of proxy, because with this Objective-C header, you have control over that. While using a framework directly, you won't be able to do this. You have to follow whatever patterns applied developers, third-party developers. And sometimes they just don't even know about Xamarin, so they don't care about asynchronous stuff. They're still using callbacks. They don't care about a lot of stuff.
Sometimes for a binding, it's like, just get it to work, it doesn't matter, right?
Yeah, for a test approach, it's totally fine, and it's the first thing you would like to try.
Yeah.
But later, whenever you try to support it, whenever you try to maintain it, it is a better approach.
Nice. Beautiful. Thank you so much for showing this off. Bindings, they seem scary, but they're really not. Just follow the guide, go through it, and I'm assuming once you do it once, it's probably like butter after that. It keeps getting easier and easier because you get used to the syntax.
That's right.
Beautiful. Well, thank you so much. And of course, we'll put links to the source code project, to the blog post, to the read through, to the links to the Objective Sharpie, and to the Swift tools. Alexey, thank you so much for coming on, showing it off.
Thank you for having me.
Awesome. Well, thanks everyone for tuning in. Make sure you check all the links in the show notes below. And don't forget to subscribe, ding that bell, do all the things, like, subscribe, all that shenanigans. And thank you so much for watching, and have a great day. Hey, James here. Just wanted to check in and thank you for watching this video. Now do all the things that you know you want to do, such as like, subscribe, and ding that notification bell to become part of the notification squad. While you're here, check out all these awesome videos that I've already recorded. Click on that thing. Click it. Watch it. Do it.